So let's do example 2. It says find missing measures in isosceles triangles. That's the topic. So we have this figure here. You have it in your book on a grid so you can count it out. The first thing we have to do is determine whether or not this is actually an isosceles triangle. So there's a couple ways to count this out and kind of cheat your way around. So I'm going to show you the right way to do this one, and then on the next one I'll show you the kind of educated cheater way. So first things first, I need to figure out if this truly is isosceles. So I'm going to use the distance formula. We have this written down a whole bunch of times. It's in the reference sheet that's on Google Classroom if you need to go back and look at that. But first thing, I'm going to find the distance from A to C. So I'm going to have my x1, y1, x2, y2, and I'm going to have -4 minus 0, and then -2 minus 3 squared. I'll go below. I'm going to have -4 minus 0 is -4. -2 minus 3 is -5. So this becomes 16 positive and 25 positive, which is going to be the square root of 41. And I'm just going to leave it right there for a second and see what happens on the next one. And then I'm going to do AB the same way. So I'll have x1, y1, x2, y2. So I'm going to have 4 minus 0. And then -2 minus 3. Of course, both of those are squared. I just didn't say it. Then we'll clean this up. So 4 minus 0 is 4. And 4 squared, it's going to be 16 in just a minute. -2 minus 3 is -5 squared. So we've got 16 plus 25 again, which is the square root of 41. So that means that these two sides are equal to each other for sure, without a doubt. Now on this one, in the book they show you to do the distance formula. Just count it. On the x-axis we start at -4. -4 to 0 is 4 units. 0 to positive 4 is 4 units. So we know that distance there is 8. It's not equilateral, but it is definitely isosceles. So now where we go from there, they want us to find the missing angles. They want us to find the measure of angle B and the measure of angle C. Well, we know that angles in a triangle have to add up to 180. So 180 minus 70 is going to leave us with 110, right? And then divide that by 2. That gives us 55 degrees for the measure of angle B and the measure of angle C. And so there we go. Good stuff right there. Okay. On the check problem, same thing they want us to do on the check problem. You can do the distance formula again. One of the ways we can kind of cheat, we go from 1 to 7 on the y-axis, so I know that length is 6. And then to kind of count my way, I know this is not going to be 6 units, so, but if I go up 3 and over 3 from x to y, and from x to z, I go down 3 over 3, that's the same number up and over, down and over. So I know that those have to be congruent to each other. You can do the distance formula, check me, but I know it's going to work. So then we have to find the 2 missing angles, but we already have 90 degrees used. So I have 90 degrees left, chop it in half, 45 degrees for each of those angles. Easy peasy. All right. There's a couple of corollaries at the bottom of 327. A corollary is just another word for a rule. This is stuff we've already talked about. It says a triangle is equilateral if and only if it's equiangular. Well, they have to be the same. If all the sides are equal, all the angles definitely have to be equal. And then each angle of an equilateral triangle measures 60 degrees. Well, 180 divided by 30 gives you 60. So that's rocket science right there. Now, how you're going to use this stuff is in situations like this. So we don't know a whole lot about this triangle, but what they want us to do is fill in all the missing stuff. This is kind of example 3 at the top of 328, my version of this. So what I know is that this side equals this side, right? Which means that those angles opposite have to be congruent. So if this angle is 60, I know angle K here has to be 60. And then because triangles always add up to 180, I'm only left with 60 degrees right there. So I know this has to be an equilateral triangle because it's also equiangular, which means if these two sides are 12, this side is also 12. So we would fill in the blanks as we go. When we take these concepts and move on where we actually get to put a little bit of algebra in it, that's where you end up with the problems like example 4. So on example 4, I want you to think about how you can reason this out to then go on and find X and Y. And it's kind of hard to see on some of these pictures what parts are equal to each other, but they do have the little marks on these two sides to show that those are congruent. So look at what we've got. These two sides are equal. Opposite this one is 60 degrees, which means opposite this one also has to be 60 degrees, right? So that means that if I'm going to find X, I can take 6X plus 6 and set it equal to 60, and I can solve that out. So subtract 6, divide, and we end up with X equals 9. So, since now I know this angle is 60 and this angle is 60, I also know this angle has to be 60, which means that this side is also congruent to the other two. Then when I'm trying to find X, I can set these two parts equal to each other. So I can say 4y minus 2 equals 2y plus 2. And I can solve that out. Subtract 2y. Add 2. And then divide, and you get y equals 2. So there's your two answers. They didn't ask us to go any further and plug anything in, but we could do that if we needed to. All right, then they have the check problem that uses the same kind of idea. So we see that we have these two angles congruent to each other because they're 2x. And then we know that these two sides are congruent. Well, opposite that side, that I don't have anything down here to measure the side for, is the 2x. It has to be the same opposite that one. So I know that this angle also has to be 2x. So when I go to solve for x, I'm going to have 2x plus 2x plus 2x. This is just one way to do it. Equals 180. Combine your like terms. 6x equals 180. Divide by 6. And x equals 30. Another way of doing that is, since we know that all three of those angles are 2x, we know this is an equiangular triangle. So I know that all of those angles have to be 60 degrees. And so if I just take that, I would have ended up in the same place. X is still equal to 30. So either way works on this one. And then when we go to find the sides, we know that all of the sides have to be equal because all of the angles ended up being equal. So I know that this has to equal this. So I can say 4y minus 5 equals 115. Add 5. And divide by 4. And y equals 30. Again. So that's all they asked us for on that one. Those shouldn't be too awful terrible for you to get through. That one is about the Louvre in Paris.